Hello everyone and welcome to our channel. Today, we'll tell you all about scientists thinking that there could be life on Titan, and it's even weirder than we thought. Is there any chance for us on the Titan? Let's find out. So without further ado, let's get started. Based on the many gravity readings that Cassini took of Titan, scientists found that the moon hides an ocean of liquid water below the surface that is probably tainted with salts and ammonia particles. In 2005, when the Huygens probe fell to the surface, it picked up radio messages. This was done by the European Space Agency. The strength of these signs strongly suggested that there was an ocean below the ice that was 35 to 50 miles, 55 to 80 kilometers, deep. The discovery of a global ocean of liquid water has added Titan to the small group of worlds in our solar system that might have ecosystems that are good for humans to live in. On Titan, there are also rivers, lakes, and seas of liquid methane and ethane that could possibly be a place where people could live on the moon's surface. Any life that might live there, though, would almost certainly be very different from life on Earth. Because of this, Titan might be able to support ecosystems that are good for life. These ecosystems could include both life as we know it, in the ocean below, and life as we don't know it, in the hydrocarbon liquid on top. Unfortunately, there is no proof of life on Titan at this time. However, the planet's complex chemistry and unique settings will make it an interesting place to study further. Titan, Saturn's moon, would not be a good place for germs that are similar to those on Earth to live, even when compared to other alien worlds. It doesn't have a global ocean like Europa and Enceladus do, so its temperature isn't as warm as Mars. On the other hand, it looks surprisingly earthly in one way. It's full of lakes with wavy shorelines. There is no water in those lakes. They are full of methane and ethane. It can get as cold as 300 degrees Fahrenheit there, so anyone who lives there would have to deal with that. But there is a chance that life will appear in places where there are liquids. Specifically, some experts say that life could be made from a certain chemical building block that works well in Titan's harsh environment. Titan is the only object in the solar system with rivers, lakes, and seas on its surface. It also has a methane and ethane liquid cycle, which is like Earth's water cycle. It rains methane and ethane, runs across the surface, and evaporates back into the atmosphere. It is also thought that Titan has an underground pool of water. Like Earth's, most of its atmosphere is nitrogen, with a small amount of methane making up 5%. In the equatorial areas of Titan, the ground is covered with dark dunes of hydrocarbon granules that look like coffee grounds. Ram and a colleague's latest simulation, which was published in Science Advances, shatters the idea that this kind of mixture can make life, or at least something like the bacteria we know and love. It looks like if there is life on Titan, it must be very strange. Any living thing from Earth that ends up in one of Titan's lakes will not be happy. But Titan's lakes don't have any water for life to interact with, and the temperatures are so cold that any life on Earth would freeze solid. What does a protocell to be need to do? Instead of fat, try acrylonitrile. Researchers from Cornell, led by physical chemist Paulette Clancy, who is now at Johns Hopkins University, figured out in 2015 that this molecule's special chemical properties would let one molecule attract another rather than interact strongly with the liquid around it. This would create a membrane that stays together and is flexible enough to allow movement in Titan-like conditions. After 2 years, the ALMA Observatory found direct proof of acrylonitrile molecules on Titan at levels high enough to support millions of single-celled organisms. Ram was impressed by the Cornell team's idea, especially their incredibly accurate prediction that Titan's life cells would be made up of just one molecule that would have a certain shape under certain circumstances. Astrobiology, the study of possible alien life, doesn't usually come up with clear answers that can be tried with computer simulations. It's not like you can just compute out an alien, he stated. Things were different this time, though. The Cornell group showed that cells made of acrylonitrile could live on Titan without breaking down. But could the membranes even stick together? In water, lipid membranes form on their own, and those on Titan would have to do the same thing in the cold methane. Ram says this is not at all clear. It's about quantum mechanical calculations, and it isn't something where you can just look at the molecules. Ram and his co-worker Hilda Sandstrom made a computer script that could guess what would happen when molecules of flowing acrylonitrile hit molecules of methane at 298 degrees below 0 Fahrenheit. The molecules didn't form the flat, flexible sheet that was needed to wrap around the cell. Instead, they made a stiff crystal that looked like ice or table salt. Based on what they found, any life on Titan could not have the same thin shell as cells on Earth. Jonathan Lunine, who was on the Cornell team that first came up with the idea for the strange membranes, said that the study was excellent, but that the original idea still has some room to grow. Rahm and Sandstrom's predictions, for instance, were based on the idea that the atmosphere would only contain methane. However, Titan's lakes contain ethane and other substances that may help the molecules form a soft sheet. Lunine also thinks that if life began in a different way, it might have developed ways to make membranes on its own. Rahm talks about different ways that people might be able to get by, but he stresses that these ideas are very hypothetical and don't make sense. Titan was first thought to have a liquid water ocean below the surface, where lipid-based cells like those on Earth could grow. He thinks that living molecules may be able to skip membranes completely and depend on Titan's mostly frozen environment to keep them together on the surface. These molecules might stay stuck to a rock their whole lives, waiting for food to come their way. Rahm says seasonal changes, wind, and receding shorelines. There's movement on the surface. So far, the discussion has only been theoretical. But when NASA sends the Dragonfly drone to study Titan in the 2030s, chemists and experts from Earth may already have a list of compounds they want to find. Titan is not a nice spot to live. Liquid water can't exist because the temperature is way too low. All living things need liquid water to survive. The temperature of Titan's surface is minus 180 degrees Celsius. In a crazy theory, the impact of an asteroid, for example, could have created enough heat to melt water for hundreds or thousands of years. But Titan probably isn't a good place for life to exist right now. Scientists are still not sure how much methane is in Titan's atmosphere, though. Next time people go into space, let's see if they can find life in Titan's liquid methane, ethane, water, and ammonia. It would show us that we are not alone and that we may have been late to the party if we found life on Titan. After the first stars came out, the universe might have been full of life. Most cosmologists have thought for almost 100 years that the universe is dead, focusing on things like stars, black holes, and dark matter halos. If they found something like this, it would be embarrassing for them. The universe may have been living since the first Titan-like objects showed up, which happened about 100 million years after the Big Bang. Titan, our neighbor in space, might be the first person to tell us this big secret. That's it for today, guys. I hope you enjoyed the video. Leave a like and comment down your thoughts on this. And don't forget to subscribe to the channel. Thank you for watching.